Hello friends, I am Prithviraj Singh and I warmly welcome you to my channel Physmatics. Today we have come first time together to discuss about motion and time for class 9. As it is a very long chapter, I have divided it into two parts. This session is first part and the next session will be second part. Okay, we are starting now. Today we will discuss motion and time. First thing come in the chapter is that state of rest. What is state of rest? An object is said to be in rest when its position does not change with time. What is that written? An object is said to be in rest when its position does not change with time. It means, suppose an example we are taking. Suppose you have keep a book on a table and left it for 2 or 3 days. After 2 or 3 days, as you will come into that room, if no one has disturbed the book, the disturb your observance will be the book position is as it is, what you have left. Okay, means the position of the book doesn't change at all. We can say that here the book is at rest, or the book has the property of state of rest with respect to the table or the room. Okay, and the second topic is our state of motion. Second topic is state of motion. Okay, which is an object. An object is said to be in motion. Okay, 1 minute. An object is said to be in motion when its position changes with time. Means, if you catch an ant lightly, because it will die if you then keep it on the table, and as soon as you left your position, the ant will escape. Means that ant's position is changed with time. Okay, so from this example we can conclude that ant is in motion with respect to you, with respect to table, and with respect to the room. I am using the term with respect to because motion has a property of being relative. Means motion is not absolute, motion is relative. I am describing it in detail. Here we will take an example. Suppose your friend has come to the railway platform to set off with you, but accidentally he has left. Okay? Or the better example will be, you are going Delhi to Calcutta. Some other passengers are waiting for another train on the platform, and with you, other passengers are in the train sitting with you. The train leave of the station, starting leave of the station. Then we observe that your position changes with time. If we see with respect to the platform passenger, means the passengers who are on platform and you are in the train, your position is changing, or you are in state of motion with respect to the passengers who are on platform. Okay? And other example of this will be, you are sitting in the train and other passengers are also sitting in the train. If yours beside passenger is sitting in the train firmly, then we observe that as time passes, distance between you and your beside passenger does not change at all. Means you are in rest in the first case, you are in rest in this case, and you were in motion in that case. Okay? We have seen here motion is relative, not absolute. And we will now see position of a particle along a straight line. Okay? Position of a particle along a straight line. Here we draw a straight line. Midpoint called O means origin, or reference point it is called. Okay? And suppose a particle A, we have divided it into two equal segments. Okay? 1, 2, 1, 2. Suppose that these are meter segments. Okay? Now suppose a particle, we have considered this direction as positive and this direction as negative. Okay? Suppose a particle or an object goes right of the origin, means this side, and we have taken this side as positive. Okay? We have taken this side as positive. Then if after 2 seconds the position of a particle is on 2, we will say that its position is plus 2 meter. Here it's the unit of length. Okay? And it's called the magnitude. Okay? And it is plus sign, but it is here to denote the direction. Means this direction. In this direction, particle has gone through 2 meters in 2 seconds. Okay? But if the particle went the left side of the origin, means in this direction, the minus direction, after 2 seconds it will be in here, means we will denote it as minus 2 meter. After 2 seconds its position will be minus 2 meter. Okay? Here also minus is for denoting the position. But this rule is not applicable in space or a vast field, because there are numerous of directions, or say infinite of directions. So here are only two directions. We have considered one as positive and second as negative. Now we will discuss physical quantities and types of physical quantities. Okay? What is physical quantities? The quantities which I am writing the definition of physical quantity. The quantities which can be measured. Okay, the quantities which can be measured. For example, mass, time, height, etc. Okay, the quantities which can be measured are called physical quantities. It is clear from this definition, means measured means it has some unit. Okay, and unit means like kg, gram. Okay, mass, SI unit of mass is gram, and SI unit of time is second, and SI unit of height is meter. Okay, and there are two types of physical quantities. There are two types of physical quantities. First is scalar quantity. Second is vector quantity. Okay, what is scalar quantity? The quantities which has only magnitude is called or are called scalar quantity or scalar quantities. We have not included in the definition the term unit because all the physical quantities have unit. So we not use term unit for the specially defining the two quantities. Okay, the quantity which has only magnitude, not direction, is called scalar quantity, like mass, time, distance, speed. Okay, density, volume, and here vector quantity. What is vector quantity? The physical quantity which have magnitude as well as direction are or is called vector quantity or quantities. Okay, means force, acceleration. Examples are force, acceleration, displacement, velocity. Okay, now we have understand the terms physical quantity, scalar quantity, and vector quantity. We will describe here distance traversed and displacement. So as I had said, distance is scalar quantity and displacement is vector quantity. I am describing it. This is distance traversed. Okay. Okay, this means the actual total measurement of length along the path is called distance traversed. For example, we will take initial position A and final position B. Means arrive point is the point which will be arrived by the particle or an object is called final positions, and the leave of position is called initial position, like A and B. If a particle goes like this, then the total measurement of distance of this actual path will be the distance traversed. Okay. What is displacement? The second term comes displacement. As I have said that displacement is a vector quantity, means it has direction as well as magnitude, or you can say it has magnitude as well as direction. Okay. What I am saying is that the shortest straight path joining the initial and final positions. Okay, what is this? The shortest straight path joining the initial and final positions is called displacement. Means, for example, we can take initial position A and final position B. If we go like this, the shortest path from A to B, or and a straight line joining initial and final positions is called displacement. The length of this path will be the displacement. Okay. Now the next term comes. I am calculating the displacement is somewhat complicated. Means you have gone in the north 2 kilometers. Okay. And along the east 3 kilometers. Okay. So if we have to calculate the distance traversed, it will be 5 kilometer. 2 kilometer plus 3 kilometer, 5 kilometer. But if we have to calculate displacement of this path, then we will join by a straight line initial and final positions like this. Okay. This will be the displacement of this path. If you see here, it can be derived, the length of this path can be derived by two methods. Consider it as a rectangle. Okay, it is not a rectangle, but you can make up that this is a rectangle. Then it's the diagonal. See, the formula of diagonal is root under L square plus B square, means length square plus breadth square is equal to हो जाएगा. L square is what? Our length is this. This is 9 and breadth is 2 kilometers, means 4, and 4 kilometers here outside the root. The length of this will be root 13 kilometer. This is the first method to find the length of this path. And the second method is we can imagine it as a triangle, as it is a triangle, right angle triangle. Then it will be the base, or perpendicular, you can take it. The formula will be, means this will be called hypotenuse square. Because this will be called hypotenuse. In the equation we have to use hypotenuse square, and this is the base and this is the perpendicular. Okay, now put the values here. H square is equal to, 1 minute, some disturbance is here. Here H square is equal to P. What was our perpendicular? This was our perpendicular, means here 4 plus base is 3, that is will 9, and then H is equal to root 4 plus 9. Here kilometer you can give, and here also. Then this is our hypotenuse, and the value of hypotenuse has come root 13 kilometer. Our both answers are same, means it's right, and the length of this hypotenuse is root 13 kilometer. Okay, now we will discuss about speed. Okay, what is speed? What is speed? Speed is a scalar quantity. Speed is a scalar quantity in which, or which has only magnitude, and speed is defined as the rate of covering distance per unit time. Write down. Speed is defined as the rate of covering distance per unit time. Means speed is equal to distance by time. Okay, from this equation we can derive time is equal to distance by speed, and from this equation we can derive distance is equal to speed into time. Okay, speeds are of two types. First is uniform speed and second is non-uniform speed. First is uniform speed and second is non-uniform speed. Okay, first and this is second. What is uniform speed? I have said that speed is defined as the rate of covering distance per unit time, and uniform speed is defined as if an object covers equal distances in equal interval of time, however the interval is small, it doesn't matter. Means in each second an object is covering 2 meter, the second it will cover 2 meter, and the third second it also cover 3 meter, then the whole journey of 3 seconds it has uniform speed of 2 meter per second. Okay, and the second comes non-uniform speed, means an object is covering unequal distances in equal interval of time, means in each second the covering distance is not equal, means first second it has covered 2 meter and the second it has covered 3 meter, like this. Okay, now the next and the most important, means one of the important term is velocity. As I have said that, what is velocity? Velocity is, what is velocity? As I have said that velocity is a vector quantity, so it has magnitude as well as direction. Okay, it has magnitude as well as direction. Then what will be there? Like, its definition will be as follows. I am writing here. it's like this. Means what is velocity? Velocity gives direction to the magnitude of speed. Means if we know our speed, we cannot calculate velocity. If we know only our speed, but if we know velocity, we can derive speed from here in a straight line motion. Not that I am deriving the speed from velocity in straight line motion. Okay, velocity has two terms. First as initial velocity and second as final velocity. Means I have started my journey. My initial velocity means starting. My starting velocity is 0 or 10 or 20, and I am increasing my speed and reached my destination. Reaching my destination, I have a top speed of 20 meter per second, from 0 to 20 meter per second, and then I reached my destination. My velocity is decreasing and going in the decreasing direction and comes to finally 0. So you have understand, initial velocity means starting velocity of the journey, and final velocity means the final velocity of the journey. Okay, as I said, velocity has a direction. It means velocity is direction in the direction of displacement. Okay, the second definition of velocity is as follows: the rate of covering displacement per unit time. Okay, and velocity has related two terms like uniform velocity, and first is uniform velocity and second as non-uniform velocity. Okay, now what we see here, first term is uniform velocity and second one is non-uniform velocity. Means what is uniform velocity? As like uniform speed, but something here is different. The rate of means an object is covering equal displacement in equal interval of time. Okay, and non-uniform velocity will be an object is covering unequal displacement in equal interval of time. Means in each second it is covering unequal displacements. Okay, as velocity is a vector quantity, it can be changed. Means if its direction is changed, means the displacement is in this direction. When displacement changes direction to the minus negative direction, then the velocity's direction is changed, means velocity is changed. It is not required to change the velocity to with the magnitude changing. Okay, and if its magnitude changes, then also velocity changes. Velocity can be changed through two cases. First one is changing of direction and second one is changing of magnitude. The unit of speed and velocity is meter per second. This is meter per second. Okay, both unit are meter per second. Now our final topic of this session is acceleration. Okay, acceleration. What is acceleration? What is acceleration? The rate of change of velocity. If it is not clearly visible to you, I am saying clearly because my marker has died off somehow. What is acceleration? The rate of change of velocity is called acceleration. Means I have said that there is some initial velocity and there is some final velocity. My velocity has changes and its rate per unit time will be my acceleration. And acceleration in straight line means there are two directions only. First one is positive direction and second one is negative direction. Acceleration's formula is final velocity acceleration is equal to final velocity minus initial velocity by time. Okay, then we will can calculate our acceleration of the given journey. Acceleration is a vector quantity, so it has magnitude and as well as it has direction. Means acceleration is a direction of its motion. Means its motion is in this direction, the acceleration is the direction of this. Okay, now we will see the term deceleration. Acceleration is somewhat, however, called also increasing of the speed. Rate of increasing change of speed means your initial speed is 0, initial velocity is 0 and final velocity is 10. Then your velocity is increasing. Here is the case of acceleration. Okay, and now we will come to the term related to it, retardation. This is retardation, which means my velocity is decreasing. For example, we can suppose that I have playing with a ball like that and I have throw a ball up. Its initial velocity was something, okay, and it becomes 0 as its velocity becomes 0 when it reaches the top position, and then it starting comes down. Okay, it started comes down, then its velocity gradually increases, and in the first case velocity was decreased to the 0. Then here is the case of first case is the case of retardation and second is the case of acceleration. Retardation means the decreasing change of velocity, means like first case of the throwing a ball. Okay, now we have completed our session. If you have understand, you can comment, and if you have any doubt you can also comment, and subscribe my channel if my videos help you. Okay, then bye.